Hi there, you're in the lab with mate JJ. Today is Old Book Teardown Day. Today's Old Book Teardown Day. My silly job title for today is Technical Director. Today I'm the Technical Director. The book that we'll be going through today is Volume 6 of Encyclopedia of Electronic Circuits. We've already done the first 5 volumes. This is the 6th volume. It's the penultimate volume. Next week we'll be doing Volume 7 and we'll be done. So today we're going to pop over to the bench and we're going to have a look what's inside this venerable tome. Here on the bench, this is our book. Authors are Rudolf F. Graf and William Sheets. That's Graf Sheets. Yuck, yuck, yuck. With cumulative index. So the previous 5 volumes are all indexed in the index of this book. It's called the Encyclopedia of Electronic Circuits, Volume 6. I don't know if that's yeah, I think that's rubbed off the other book in the book on the bookshelf. Acclaim for previous volumes. Modern Electronics said, a ready source to which to turn for just about any type of circuit you can imagine. And Electronics for You said, a virtual treasure house, an invaluable reference tool for every hobbyist, technician, student, and design professional. And the Industrial and Process Control magazine said, for professionals who need fast answers to specific design problems. And the American Reference Book Annual said, highly recommended, truly an invaluable storehouse. There you go. More than 1,000 of the most functional, widely used electronic and integrated circuits at your fingertips. The sixth volume in the series of peerless, best-selling references provide you with a huge collection of circuits for virtually every type of electronic device. With these state-of-the-art circuit drawings developed from late 1992 through early 1995, you'll be able to design the optimum circuit with the minimum of time and effort. Arranged alphabetically by circuit type, this massive resource offers a cumulative index to all 6 volumes of the Encyclopedia of Electronic Circuits. Contains circuit schematics used in alarm and security systems, amplifiers, computers, converters, fiber optics, generators, lasers, detectors, oscilloscopes, receivers, temperature sensors, transmitters, and many more electronic devices. Yeah. So let's pop it open and see what's in here. What are you doing? All right. Published 1996. There you go. Can you see that? All right. So we've got contents, and then we've got 104 chapters and 1-page introduction. All right. Well, let's read the contents. So there's an introduction, and then we're off. AGC and ALC circuits, airflow circuits, alarm and security circuits, amateur circuits, amateur television ATV circuits, amplifier circuits, analog digital converter circuits, antenna circuits, attenuator circuits, audio signal amplifier circuits, audio power amplifier circuits, automotive circuits, battery charger circuits, battery monitor circuits, bridge circuits, buffer circuits, clock circuits, computer-related circuits, continuity circuits, converter circuits, crystal oscillator circuits, current source and sink circuits, DC-DC converter circuits, decoder circuits, delay circuits, detector circuits, differential amplifier circuits, display circuits, driver circuits, electronic lock circuits, fiber optic circuits, filter circuits, flash circuits and blinkers, flip-flop circuits, frequency to voltage converter circuits, function generator circuits, gain circuits, humidity sensor circuits, indicator circuits, infrared circuits, instrumentation amplifier circuits, integrator circuits, interface circuits, inverter circuits, ion circuits, laser circuits, light controlled circuits, logic circuits, mathematical circuits, measuring and test circuits, metronome circuits, miscellaneous treasures, mixer circuits, model and hobby circuits, modulator circuits, Morse code circuits, motor control circuits, multivibrator circuits, noise circuits, operational amplifier circuits, oscillators, audio, oscillators, miscellaneous, oscillators, RF, oscilloscope circuits, photography-related circuits, piezo circuits, power line circuits, power supply circuits high voltage, power supply circuits multiple output, power supply circuits variable output, probe circuits, protection circuits, radar detector circuits, radiation detector circuits, receiving circuits, reference circuits, regulator circuits, relay circuits, sample and hold circuits, sawtooth generator circuits, scanner circuits, siren, warbler, and wailer circuits, sound effects circuits, square wave generator circuits, staircase generator circuits, stepper motor circuits, switching circuits, sync circuits, telephone related circuits, temperature related circuits, timer controls, that's timer circuits, tone control circuits, touch/proximity control circuits, tracer circuits, transmitter and transceiver circuits, ultrasonic circuits, video circuits, voltage controlled amplifier circuits, voltage controlled oscillator circuits, voltage measuring circuits, waveform generator circuits, waveguide circuits, white noise generator circuits. Then we've got sources, index, and about the authors. This is the introduction by Rudolf F. Graf and William Sheets, September 1995. The enthusiastic reception of the first 5 volumes of the Encyclopedia of Electronic Circuits prompted the authors to produce this volume, the 6th in the popular series. Taken together, the 6 volumes contain approximately 6,000 circuits, by far the largest and broadest collection of practical electronic circuits available anywhere. As in the other volumes, the 1,000 plus circuits presented here are arranged alphabetically by category. All circuits in this volume, as well as those from the previous 5 volumes, are included in the index, which now has approximately 6,000 entries. We express sincere appreciation to the many electronic industry sources and publishers who graciously allowed us to utilize some of their materials. Their cooperation is gratefully acknowledged. Once again, it gives us great pleasure to extend our sincerest thanks to Loretta Gonçalves Batiste, a fine lady whose skill at the computer and willingness to work long and hard made on-time delivery of the manuscript for this book possible. There you go. All right, well, I'm going to take a quick break before we hook in. I'll be right back. All right, well, I got myself a coffee and I filled up my water bottle, so I am ready to go. So let's have a look what's in this book. AGC and ALC circuits. AGC audio preamp, 3 MHz low noise AGC system, IF AGC network, audio leveler. AGC audio preamp. The circuit uses an easily obtained 741 op-amp set for an internal gain of about 200. A portion of the op-amp's output signal is rectified by the 1N4148 diodes, then filtered and fed to the gate of the FET input shunting circuit. As the output rises, more and more input shunting takes place. That is, more of the input signal is bypassed, effectively keeping the output level constant. The circuit offers a 100-to-1 limiting action. The input level can change over a 100-to-1 ratio with little or no effect on the output level. The output level itself can be set from less than unity all the way up to nearly the gain of the amplifier, making the circuit usable in other applications as well. I'm going to look up AGC. I'm not sure what it stands for. All right, so AGC is automatic gain control and ALC is automatic level control, where the AGC is focused on the input side and the ALC is focused on the output side. But they're basically about allowing the inputs and to vary without the outputs varying too much. All right, so this is a 3 megahertz low noise AGC system, an IF AGC network. IF is that intermediary frequency. Are we going to have to look it up? I suppose we are. I'll be back. All right, I'm back and I've got my notebook out. Make some notes as we go. Of course, IF is intermediate frequency. And then we've got an audio leveler. There we go. Airflow circuits. Hot wire anemometer. An electronic anemometer. And an airflow detector. Hot wire anemometer. An anemometer can be realized by utilizing the inherent transconductance match of transistors in the array instead of passive series resistances to control filament current. As a result, as A1 serves the collector current of Q4 and thereby the voltage across R1, it simultaneously adjusts the filament, a 2182 type incandescent lamp denuded of its glass envelope. Okay, voltage VF. And off we go. All right, so that's a hot wire anemometer. And I guess the hot wire is the denuded lamp, incandescent lamp. All right, electronic anemometer, airflow detector. The self-heating of a semiconductor that is cooled by airflow is used as a sensing method. Fascinating. Alarm and security circuits. Burglar alarm circuit, auto security system transmitter, home security system, auto security system receiver, flashing brake lights for motorcycles, car alarm decoy, motorcycle alarm, simple bike horn, door ajar indicator, motorcycle burglar alarm, horn circuit for motorcycle use. Burglar alarm circuit. I love these old circuits that have like logic in them. It's a 4081, so some sort of quad NAND gate. No, quad and 4081 logic. It's early CMOS logic. Auto security system transmitter. The M145026 programmable digital encoder. There you go. Home security system from Popular Electronics. Auto security system receiver. Was there an auto security system sender? Must have been the previous circuit. At the heart of the main control unit is U16 Zilog's Z8 8-bit microcontroller, which receives its program instructions from U17, a 27C64 8K by 8 EEPROM. The home security system, in its most basic form, features 8 individual protection zones, adjustable entry and exit delays, a panic switch for emergency situations, automatic system reset, support for an auto dialer, which in case of emergency dials pre-programmed telephone numbers. It's X10 compatible, allowing it to control house lights and appliances. Has a backup battery to keep the system online during a power failure, and there is also an optional zone status panel that is used to individually show the condition of each protection zone. This system's power supply provides 12-volt DC for the sirens and digital keypad, and 5-volt DC for the onboard electronics, while also providing a constant 12-volt output that's used to charge the backup battery. Well, if it's running on a microprocessor, it's or a microcontroller, it calls it. It's going to need code. Guess you have to go to the Popular Electronics article for the code. This receiver is a super heterodyne type tuned to 49 megahertz. U2 is a mixer, followed by a 10.7 megahertz filter and two-stage intermediate frequency U3, U4 and detector. The decoder received RF pulse signal from the antenna, produces detected pulse from the MC1330P. These pulses are amplified by U5 and fed to the decoder unit U6 and MC1450-278. Two channels are available at output, which drives K1 and K2. Flashing brake light for motorcycles. Okay. Uses a MOSFET, an IRF 511. Looks like a MOSFET. Q1. What does it say about it? Doesn't say. Just says Q1. When brake light switch S1 is closed, power is applied to U1 and U2. Two inverters of U2, a 4049 hex inverting buffer, are connected in a low-frequency oscillator circuit that feeds clock pulses into U1. A 4017 decade counter/divider. Outputs 0, 2, 4, 6, and 8 of UC1 are coupled to the gate of Q1 through a 1N914 diode. As the 4017 counts down, it turns the brake light on and off 4 times and then leaves it on until the brake switch is released. The on-off rate can be set by potentiometer R2. For best results, the on-off rate should be set so that it is rapid. There you go. Car alarm decoy. The device will simulate the presence of a burglar alarm in automobiles or homes. Mount R1 where daylight can fall on it. During darkness, a LED one flashes, making potential intruders think an alarm system is installed. Motorcycle alarm. Simple bike horn. Door ajar indicator. Motorcycle burglar alarm. Horn circuit for motorcycle use. Amateur circuits. 1.2 kilowatt, 144 megahertz amplifier power supply. 1.2 kilowatt, 144 megahertz amplifier control circuitry. 1.2 kilowatt, 144 megahertz linear amplifier. 4-stage 75 meter SSB superhet receiver. Improved CW transmitter keying circuit. 1-chip AFSK generator. Programmable CW identifier. Audible SWR detector adapter, audio breakout box, 1-watt CW transmitter, PTT control from receiver audio. PTT is push to talk. Transceiver memory backup, 80 meter SSB receiver, CW audio filter, RF line sampler/coupler, battery pack and reverse polarity protection, simple identifier, transmit care interface circuits, mobile radio on alarm timer. 1.2 kilowatt, 144 megahertz amplifier power supply. 1.2 kilowatt, 144 megahertz amplifier control circuitry. 1.2 kilowatt, 144 megahertz linear amplifier. 4-stage 75 meter SSB superhet receiver. Improved CW transmitter keying circuit. 1-chip AFSK generator. Programmable CW identifier. The identifier uses an MTA81010 chip containing a 1024-bit serial EEPROM and a microcontroller. It runs from a 9-volt battery. A standard AT-type keyboard is used to program the desired message. Speed varies from 5 to 25 words per minute. Okay. I assume it uses Morse code. I don't know. Audible SWR detector adapter. This SWR detector audio adapter is designed specifically for blind or vision impaired amateurs, but anyone can use it. Instead of using a meter or meters to indicate antenna system forward and reflected voltages, this adapter generates 2 tones with frequencies that are proportional to the respective voltages. Audio breakout box. 1-watt CW transmitter. Push-to-talk control from receiver audio. Transceiver memory backup. 80-meter SSB receiver. CW audio filter. RF line sampler / coupler. Battery pack and reverse polarity protection. Oh, there you go. A 1N5400 diode is used. I didn't know about that diode. Simple identifier. This identifier uses PIC16C54 microcontroller, which must be programmed for your desired identifier. Okay. Transmit Kia interface circuits. Mobile radio on alarm timer. This system will prevent you from accidentally leaving your mobile radio on, draining the battery. Amateur television circuits. 5-watt ATV transmitter for 440 megahertz. 5-watt ATV transceiver. Mini ATV transmitter. Dummy load and video detector for transmitter tests. Mass-mounted ATV preamp. 3-channel 902 and 928 megahertz ATV transmitter. ATV down converter for 902 to 928 megahertz. 3-channel 420 to 450 megahertz ATV transmitter. ATV down converter for 420 to 450 megahertz. 5-watt ATV transmitter for 440 megahertz. 5-watt ATV transceiver. Mini ATV transmitter. Dummy load and video detector for transmitter tests. Mass-mounted ATV preamp. 3-channel 902 to 928 megahertz ATV transmitter. ATV down converter for 902 to 928 megahertz. 3-channel 420 to 450 megahertz ATV transmitter. ATV down converter for 420 to 450 megahertz. So it's basically a block diagram. Look at that. Filter, RF amp, DT filter, mixer, balanced mixer, minus half a decibel, intermediate frequency amplifier, 15 dB. Wow. Amplifier circuits. Operational transconductance amplifier with booster, VCR head amplifier tester, low pass amplifier, high pass amplifier, ISD 10,000 or 1000 amp record playback circuit, 1000 A. Is it amp? I don't know. Remote amplifier, programmable gain amplifier, programmable input amplifier, remotely powered sensor amplifier, tuned amplifier, difference amplifier with wide input common mode range, bandpass amplifier, high side current sensing amplifier, high input impedance AC amplifier, MOSFET push-pull amplifier, low voltage microphone preamp, basic logarithmic amplifier using op-amp, crystal tuned amplifier. Operational transconductance amplifier with booster. VCR head amplifier tester. Low pass amplifier. High pass amplifier. ISD 100A record/playback circuit. ISD 1000A. The circuit uses the Information Storage Devices ISD 100A chip. Radio Shack part number 2761325. There you go. Remote amplifier. Programmable gain amplifier. Programmable input amplifier. Remotely powered sensor amplifier. Tuned amplifier. Difference amplifier with wide input common mode range. Band pass amplifier. High side current sensing amplifier. High input impedance AC amplifier. MOSFET push-pull amplifier. Low voltage microphone preamp. Basic logarithmic amplifier using op-amp, using the 741. Crystal tuned amplifier using a Max 436 amplifier. Analog digital converter circuits, high speed analog digital converter system, analog digital converter for PCs. High speed analog digital converter system using AD9058. The AD8001 is well suited for driving high speed analog to digital converters such as the AD9058. The AD9058 is a dual 8-bit 50 mega samples per second ADC. That's an analog to digital converter, 8-bit. In the circuit shown, there are two AD8001s driving the inputs of the AD905F8, which are configured for 0 to 2 volt ranges. Bipolar input signals are buffered, amplified, and offset into the proper input range of the ADC using the AD9058's internal plus 2 volt reference connected to both ADCs, as shown, reduces the number of external components required to create a complete data acquisition system. The 20 ohm resistors in series with the ADC input are used to help the AD8001 drive the 10 picofarad ADC input capacitance. The two AD8001s only add 100 milliwatt to the power consumption while not limiting the performance of the circuit. Analog to digital converter for PCs. An ADC0804 AD converter converts analog data to digital. This is fed to a 74165 8-bit shift register and converted to serial data. U3 provides a baud rate clock. U4A and U4B are used to generate start and stop bits needed at beginning and end of each data word. Right. Antenna circuits. Remote tuned active HF antenna, miniature broadband antenna 3 to 30 megahertz, FM audio radio diversity antenna, tunable FM antenna booster, matchbox antenna tuner, active antenna for UHF scanners. Remote tune active HF antenna. Look, it's got a PCB for etching. Isn't that fun? Remote tuned active HF antenna. Miniature broadband antenna, 30 to 30 megahertz. Antennas are like magic to me. I don't get them. FM auto radio diversity antenna. FM auto radio diversity antenna continued. Tunable FM antenna booster. Matchbox antenna tuner. Antenna tuner. Active antenna for UHF scanners. Attenuator circuits. Switchable power and switchable power attenuator. Variable voltage attenuator. It's a switchable power attenuator. Variable voltage attenuator. Audio signal amplifier circuits. Vacuum tube audio amplifier. Micro power linear amplifier. MB FM audio amplifier. 2 transistor audio amplifier. Personal stereo audio amp. Transistor RIAA preamp for magnetic phone cartridges. Dynamic microphone preamp. Balanced microphone preamplifier. RIAA line amplifier / driver. Single-ended high Z microphone preamp. Low level audio amplifier. Simple 20 decibel gain audio amplifier. High gain dynamic microphone preamplifier. FET phono cartridge preamp. Simple high gain audio amplifier. RIAA preamplifier. Basic complementary class AB single supply amplifier. High impedance microphone input circuit. Electronic ear low noise audio amplifier for parabolic dish mics. Parabolic dish. Vacuum tube audio amplifier. Micro power linear amplifier. MB FM audio amplifier. 2 transistor audio amplifier. Personal stereo audio amp. Transistor RIAA preamp for magnetic phone cartridges. This 2 transistor circuit has around 40 decibel mid-band gain at 1 kHz. A magnetic cartridge is used as a source. Dynamic microphone preamp. Balanced microphone preamplifier. RIAA line amplifier / driver. 2 op-amps by analog devices are used in this audio line amplifier, which is suitable for interfacing with an RIAA preamplifier. Single-ended high Z microphone preamp. Low-level audio amplifier. Simple 20 decibel gain audio amplifier. You can use any LM741, LM324, LM1458. Pretty basic. High gain dynamic microphone preamplifier. FET phono cartridge preamp. Why is it called a FET? I'm not seeing a FET. Oh, that must be the MPF 102. Yeah, right. Simple high gain audio amplifier. RIAA preamplifier. Basic complementary class AB single supply amplifier. High impedance microphone input circuit. Electronic low noise audio amplifier for parabolic dish mics. Audio power amplifier circuits. Audio power amplifier 1.5 watt 12 volts. Parallel power op amps, 10-watt audio amplifier, power bridge amplifier with single-ended output, line-operated audio amplifier, basic complementary class AB power amplifier, simple vacuum tube amplifier, power supply for vacuum tube amplifier, 16-watt bridge amplifier, RFI-proof audio power amplifier, basic quasi-complementary power amplifier with split power supplies, RIAA phono amplifier, basic quasi-complementary power amplifier circuit, phone amp, 80-watt IC audio amplifier, basic complementary power amplifier circuit, general purpose AF amplifier, bridge connection of 2 power op amps, 90 volt 10 amp high power amplifier, mini megaphone. Audio power amplifier, 1.5 watt 12 volt. Parallel power op amps, 10 watt audio amplifier. Power bridge amplifier with single-ended output. Line operated audio amplifier. Basic complementary class AB power amplifier. Simple vacuum tube amplifier. Power supply for vacuum tube amplifier. 16 watt bridge amplifier. RF proof audio power amplifier. Basic quasi-complementary power amplifier with split power supplies. RIAA phono amplifier. Basic quasi-complementary power amplifier circuit. Phono amp. The figure shows the LM380 with the voltage divider volume control and high frequency roll-off tone control. 80 watt IC audio amplifier. Basic complementary power amplifier circuit. General purpose AF amplifier. Bridge connection of 2 power op amps. 90 volt 10 amp high power amplifier. Mini megaphone. 12. Automotive circuits. Electronic auto stethoscope. Automotive electrical monitor. Car alternator monitor. Idiot light. Okay. Cigarette lighter 9 volt adapter. Motorcycle turn signal system. Tachometer signal conditioning circuit. Smart turn signal for autos and motorcycles. Turn signal alarm. High power audio amp for automotive installation. High power 12 volt IC auto amplifier. Capacitor discharge ignition system. Car audio power supply. Motorcycle headlight monitor. Headlight off indicator. Auto battery isolator circuit. Automotive high Z test light. I'm just going to take a quick break. Electronic auto stethoscope. The heart of the stethoscope is the NE5532 audio op amp U1. That component directly drives low impedances and allows the use of headphones without adding another amplifier. Automotive electrical monitor. Car alternator monitor, idiot light. A window comparator is used to detect a too low or too high system voltage. The minimum and maximum settings are set with two 50 kilo ohm pots as desired. Cigarette lighter 9 volt adapter. A simple way to provide 9 volts at 100 milliamps from a 12 volt auto source. Applications include small radios, cassettes, etc. Motorcycle turn signal system. Tachometer signal conditioning circuit. Smart turn signal for autos and motorcycles. Turn signal alarm. This circuit can be used to tell the driver if of a vehicle when his or her turn signal has been left on for too long. Okay, that's a bad idea. High power audio amp for automotive installation. High power 12 volt IC auto amplifier. capacitor discharge ignition system, car audio power supply, motorcycle headlight monitor, headlight off indicator, auto battery isolator circuit, automotive high Z test light. This test light has a high input impedance and draws only 1 milliamp at 12 volt. Q1 switches DC to a battery and lamp circuit. Battery charger circuits. Smart battery charger, rechargeable LED flashlight, battery charger controller, single cell lithium battery charger, battery charging current limiter, 3-cell lithium charger, NiCad battery charger, backup battery monitor charger alarm, NiCad charger / zapper, 2 to 5 cell lithium battery charger, lead acid trickle charger, NiCad battery charger. Smart battery charger. This charger will work with NiCad or the new rechargeable alkaline batteries. The smart charger is comprised mainly of 4 chips. Okay, and off it goes. Rechargeable LED flashlight, battery charger controller, single cell lithium battery charger, battery charging current limiter, 3-cell lithium charger, NiCad battery charger, backup battery monitor / charger / alarm, NiCad charger / zapper, 2 to 5 cell lithium battery charger, lead acid trickle charger, NiCad battery charger. Battery monitor circuits. Battery monitor, battery butler, undervoltage indicator for single cell, battery charger probe, low battery circuit, battery charge indicator, battery status indicator, lithium memory backup replacement, battery condition indicator for 12 volt batteries. Battery monitor, battery butler. The battery butler solves the common problems associated with the maintenance and operation of NiCad batteries. The battery butler, by initially discharging a NiCad battery to a preset point, reduces the possibility of the memory effect occurring. Once discharged, the battery is then usually charged at 25% and reduce the internal cell pressure increase by 40% or more. Once the battery is fully charged, a trickle charge is provided to maintain the battery in a fully charged state. The battery butler circuit can be bypassed and the existing fast charger used if needed. Undervoltage indicator for single cell. Battery charger probe. Low battery circuit. Battery charge indicator. Battery status indicator, lithium memory backup battery replacement, battery condition indicator for 12 volt batteries. Bridge circuits. Single supply bridge amplifier, Wheatstone bridge, bridge amplifier with low noise compensation. Single supply bridge amplifier, Wheatstone bridge. This circuit can be used to measure resistances. R7 is calibrated and fitted with an inductor dial. Then this equation, okay. A frequency of 1 kilohertz for the audio oscillator is usually used. Bridge amplifier with low noise compensation. Buffer circuits. Unity gain ADC buffer, high Z microphone buffer amplifier, wideband general purpose buffer, ADC buffer, single supply AC buffer amplifier, analog non-inverting switch buffer, voltage follower, simple bidirectional buffer design, buffer for AD converters. Unity gain ADC buffer, high Z microphone buffer amplifier, Wideband general purpose buffer, ADC buffer, single supply AC buffer amplifier, analog non-inverting switch buffer, voltage follower. Simple bidirectional buffer design, buffer for AD converters. Clock circuits, set time windows within a clock, low frequency clock. Set time windows within a clock. At times, it is necessary to produce pulses of adjustable width and whose start times might vary with reference to a master clock. The input signal is inverted and buffered by U1A, while U1B and U1C invert the signal to produce square, buffered renditions of the input signal. Potentiometers R3 and R4 set references for the comparators. Low frequency clock. The LM3090 is an LED flasher IC that is designed to oscillate at low frequencies. The clock output of the first circuit can be changed by changing the value of the capacitor, and the second circuit lets you adjust the frequency with the trimmer. B1 can be 1 or 2 alkaline 1.5 volt cells. The LM3909 can supply up to 45 milliamp pulses at greater than 2 volts. Computer-related circuits. RS422 to RS232 converter, printer port, PC password protector, key wireless RTS with data, microprocessor supervisory circuit, computer-powered RS232, plus 12 volt flash memory programming supply, EEPROM programmable doubler circuit, monitor power saver for computers. Okay, this is an RS422 to RS232 converter. Okay, printer port. A 16-step programmable current generator can be modified so that it's controllable by a printer port. This is done by switching the resistor connected between the output of the generator's OA1 op amp and the input of OA2. The CMOS single 16-channel analog multiplexer, IC1, chooses one resistor at a time in accordance with the code sent by the printer port through 4 of its 8 data output lines, pins 2 to 9. In addition, one control line, pin 1, is used to enable the operation. As a result, 16 outputs can be selected by a 4-bit word. The table shows the relationship between data word and selected resistor. The following must be fulfilled in order for the circuit to work as a true current generator. The smaller the resistor's tolerance, especially R1 through R16, the greater the output resistance of the generator. Because OA2 is connected as a repeater, the current I2 is 0, and only the load current flows through one of the R1 through R16 resistors. Okay. The Turbo C++ program also controls the current through the load. Huh. There you go. It's fun. It's got standard I/O, and then it's got DOS header, and then it defines the output port as 378, control port 37A, int data output control port 0x01, delay 1, output B, output data. One of R1 to R16 selected table. A. Yeah, right. Wow. PC password protector. IC4, it's a 43256. It's RAM. Okay. Key wireless RTS with data. This simple key supplies both the RTS control and data delay needed to interface a digital radio with an RS-232 data-only system. It supports speeds of 19.2 kilobits per second, sync or async. Microprocessor supervisory circuit. This circuit provides a reset pulse during power up, down, or low voltage battery backup, switching, a watchdog timer, and a 1.2 volt threshold detector for power failure or power fail warning, or to monitor another supply. Yeah, right. Computer powered RS-232. Commercializing battery-operated equipment that must interface to a computer via the RS-232 port runs into the problem of power consumption. To load the system batteries strictly to power the interface is unacceptable. An alternative is to let the computer that the device is connected to provide the interface as power. One snag is that the RS-232 specification doesn't have a power tap on the connector, but it does provide RTS and DTR, request to send and data terminal ready, signals that assert a negative voltage in their quiescent state. Figure 18.6a shows a simple scheme of delivering a 5 volt potential from the RTS and DTR signals. R7 and R8 and diodes D1 and D2 mix the return current to the RS-232 port so that the RTS and DTR drivers split the current drawn by the interface. This scheme, even from a laptop computer, can supply 12 milliamps to the interface. The only drawback is that the TTL device must be isolated from the computer's ground, the earth ground, because the interface treats the RS-232 ground as a positive voltage. A modified optocoupler system shifts the RS-232 level to TTL voltages. It will support up to 9,600 bits per second. C3 is charged up to about 1 volt less than the RTS voltage, while the TTL line asserts a marking state. As the capacitor is charging, Q3 is biased into saturation, thus providing a negative voltage. Blah, blah, blah. This is why USB was a good idea. 12 volt flash memory programming supply, EEPROM programming doubler circuit, monitor power saver for computers. Some good old 4011 NAND gates there. 741 op amp, a couple of NPN transistors. Continuity circuits. Short circuit beeper, adjustable continuity tester, simple audio video cable tester, audible continuity tester. Short circuit beeper, adjustable continuity tester, simple audio video cable tester, audible continuity tester. Converter circuits. WWV converter, simple HF receive converter, 225 watt 15 volt output converter, 12-bit digital to analog converter, driven flyback converter, sine wave converter, SCR converter, 5 volt 5 amp step down converter, sync to async converter, differential voltage to current converter, direct conversion 7 megahertz receiver, low frequency converter, programmable current to voltage converter, current to voltage converter with boost transistor, current to voltage converter for grounded loads, output to current converter. WWV converter. This converter heterodynes the 15 MHz WWV signal with a 16 MHz oscillator so that it can be heard at 1 MHz on an AM broadcast receiver. T1 and T2, a modified 10.7 MHz IF transformer, and AM BC oscillator coil respectively. Simple HF receive converter, 225 watt 15 volt output converter, 12-bit digital analog converter. This circuit uses an analog device's DAC 8043 12-bit multiplying DAC. The output voltage will be D divided by 4096 times Vref, where D is the numerical value of the digital input word. Vref is 1.235 volts in this circuit. Driven flyback converter, sine wave converter, SCR converter. Two SCR devices are used in a push-pull driver to convert 28 volts DC into 155 volts DC using the transformer and bridge shown. Center tap transformer with 24 volts to 120 volts could be used for 60 Hz applications. The trigger circuit supplies a push-pull drive signal. 5 volt 5 amp step-down converter. Sync to async converter. Differential voltage to current converter. Direct conversion 7 MHz receiver. Low frequency converter. This converter circuit translates the 350 to 500 kHz range to a 4.35 to 4.5 MHz, enabling the frequency range to be received on a conventional shortwave receiver. Programmable current to voltage converter. Current to voltage converter with boost transistor. Current to voltage converter for grounded loads. Output to current converter. Crystal oscillator circuits. FET quartz crystal oscillator. Crystal oscillator 1. FET VXO circuit. UJT 100 kHz calibration oscillator. Crystal oscillator with FM capability. Crystal oscillator 2. DC switched crystal oscillator. Crystal oscillator with adjustable frequency. Frequency doubler and crystal oscillator. Crystal oscillator 3. Colpitts oscillator. FET quartz crystal oscillator. Crystal oscillator 1. FET VXO circuit. UJT 100 kHz calibration oscillator. Crystal oscillator with FM capability. Crystal oscillator 2. DC switched crystal oscillator. Crystal oscillator with adjustable frequency. Frequency doubler and crystal oscillator. Crystal oscillator 3. Colpitts oscillator. Current source and sink circuits. Current generator. Voltage controlled current source. Voltage controlled current sink. Multiple fixed current source. Okay, so there's a current generator using the LM358. Voltage controlled current source. A voltage variable current source is shown in the figure. The transconductance is -1 on R2 as the voltage gain from the input terminal to the emitter of Q1 is -1. For Vn equals 0 VDC, the output current is essentially 0 milliamps DC. Resistors R1 and R6 guarantee that the amplifier can turn off transistor Q1. Voltage controlled current sink. Multiple fixed current source. DC to DC converter circuits. Isolated DC to DC converter. DC to DC converter 1. Ultra low power DC to DC converter for personal communications products. Negative step up DC to DC converter. DC to DC converter 2. Isolated DC to DC converter. DC to DC converter. Ultra low power DC to DC converter for personal communications products. Negative step up DC to DC converter. DC to DC converter 2. In this DC to DC converter, the 555 is used to produce a rising and collapsing field in T1's primary, generating high voltage in T1 secondary winding. That voltage is then full wave bridge rectified by D1 through D4 and filtered by C3. T1 is an Amidon Associates EA775375E core with nylon bobbin with 26 wire for the primary and 28 or 30 for the secondary. About 5 watts of power is available. Decoder circuits. DTMF decoder, FM stereo decoder, typical NE 567 tone decoder circuit, video line decoder 1, video line decoder 2. This is a DTMF decoder. This DTMF decoder uses a Motorola 68705P3 microcontroller and a 75T202 DTMF receiver. An LCD module is used for the display. Switch S1 is used to scroll the display. S2 clears the display and S3 clears the memory. FM stereo decoder. Using an LM1800, this circuit takes composite baseband MPX input and recovers the L7R audio channels. The VCO is set for 19 kHz or 15.7 kHz for TV applications or as needed. Typical NE 567 tone decoder circuit. The circuit illustrates the use of NE 567 as a tone decoder. Video line decoder 1. This line decoder uses only one pin for the line indicator. Video line decoder 2. This circuit will produce pulses useful for gating lines 24 and 257 of video signal, but by changing the decoding logic, other lines can be decoded. Delay circuits. Time delay generator. Simple time delay circuit. Time delay generator. Simple time delay circuit. Just using a 555 timer. That is simple. Detector circuits. High-speed peak detector with hold and reset controls, lock detector, linearized RF detector, glitch detector, VCR video detector controller, grid leak detector, negative peak detector, double-ended limit detector, positive peak detector, LM556 timer frequency detector, single comparator window detector, 15 kHz tone detector, crystal radio detector, switch closure circuit, airflow detector, low drift peak detector, negative peak detector, positive peak detector, 455 kHz AM detector, AC noise detector. High-speed peak detector with hold and reset controls, lock detector, linearized RF detector, glitch detector, VCR video detector controller, grid leak detector, negative peak detector, double-ended limit detector, positive peak detector, LM556 frequency detector, single comparator window detector, 15 kHz tone detector, crystal radio detector, switch closure circuit, airflow detector, low drift peak detector, negative peak detector, positive peak detector, 455 kHz AM detector, AC noise detector, differential amplifier circuits, basic op-amp differential amplifier, precision high gain differential amp, basic op-amp differential amplifier, precision high gain differential amp, display circuits, multiplexed BCD decoder driver circuit, color shifting LED display, stereo level display, high efficiency display contrast and backlight control, bar graph level gauge, simple color organ, voice level meter, LCD contrast temperature compensator, LED bar graph driver circuit, multiplexed BCD decoder driver circuit, color shifting LED display, stereo level display, high efficiency display, contrast and backlight control, bar graph level gauge, simple color organ, the three active filters that divide the audio spectrum into three bands, drive rectifiers, and then drive IC 2, 3, and 4, flashing the LEDs at 6 Hz. D4, D5, and D6 should be 3 different colors for best effect. Voice level meter, LCD contrast temperature compensator, LED bar graph driver circuit. Driver circuits. 2 input video mux cable driver, impedance matched line driver with 75 ohm load, test driver for hobby servos, stereo line driver, high speed shield / line driver, simple neon light driver, high side MOSFET driver, TTL based speaker driver, low distortion composite plus or minus 100 milliamp line driver, video cable driver, coax cable driver, ultra low distortion plus or minus 50 milliamp driver, very efficient solenoid driver, 2 input mux cable driver, impedance matched line driver with 75 ohm load, test driver for hobby servos, stereo line. I'm just going to read test driver for hobby servos. This circuit will generate the pulse used to control hobby servos. With the components shown, the servo should produce a 90-degree total rotation. It's just using a 555. Yeah. Stereo line driver, high speed shield / line driver, simple neon light driver, high side MOSFET driver, TTL based speaker driver, low distortion composite plus or minus 100 milliamp line driver, video cable driver, coax cable driver, ultra low distortion plus or minus 50 milliamp driver, very efficient solenoid driver. Electronic lock circuits. Electronic lock, frequency based lock, simple lock. Electronic lock. The heart of the circuit is a 4022 octal counter. When first powered up, C2 is charged via R5, so the reset input of the counter is kept high. That causes output Q0 to go high, while all the other outputs are low. With the switches wired as shown, when S4 is pressed, the BS170 is switched on via a debouncing network R2C1, and U1 receives a clock pulse. It's an octal counter. Frequency-based lock. Simple lock. Fiber optics circuits. Experimental data transmitter for fiber optics. Experimental fiber optic data receiver. All right. Oh, gee, they really phoned that one in, didn't they? I think they just put these two circuits in here so they could say fiber optics on the back. Yeah, fiber optics. Okay. These are pretty basic circuits. Yeah. Filter circuits. State variable filter, Allen key high pass filter, active bandpass filter circuit, high pass filter, second order voltage controlled filter, combination filter, shortwave receiver IF filter, pin diode filter selection circuit, high pass active filter, AM broadcast trap for simple SW receivers, shortwave interference trap, programmable analog filter, active low pass filter, 2 op-amp bandpass filter, single 3.3 volt supply, 4-pole state variable filter, high Q notch filter, adjustable Q notch filter, digital comb filter, voltage controlled low pass filter, VSB filter for LM2889, 20 kHz Butterworth active filter, bandpass filter, Allen key low pass filter, active high pass filter, RC notch filter, 1 kHz fourth order Butterworth filter, SAW filter impedance matching preamp, 1 op-amp bandpass filter. Wow, that's a long list of filter circuits. State variable filter, Allen key high pass filter, active bandpass filter circuit, high pass filter, second order voltage controlled filter, combination filter, shortwave receiver IF filter, pin diode filter selection circuit, high pass active filter, AM broadcast trap for simple SW receivers, shortwave interference trap. Build this interference trap to help block strong shortwave broadcasts and FM stations from coming in on the shortwave bands. Programmable analog filter, active low pass filter, 2 op-amp bandpass filter, single 3.3 volt supply 4-pole state variable filter, high Q notch filter, adjustable Q notch filter, digital comb filter, voltage controlled low pass filter, VSB filter for LM2889. This filter is for channel 3 in order to get a vestigial sideband TV signal. It is designed for 75 ohm impedance levels. 20 kHz Butterworth active filter, bandpass filter, Allen key low pass filter, active high pass filter, RC notch filter, 1 kHz fourth order Butterworth filter, SAW filter impedance matching preamplifier, 1 op-amp bandpass filter, flasher circuits and blinker, random LED strobe, flashing neon Christmas lights, flashing Christmas LED display, Dual flasher add-on for 555 circuits, variable frequency high power LED flasher, LED pulsar, LED pulsar with audible output, simple lamp pulsar, LED flasher, random LED strobe. This circuit generates a random output that is translated into LED movement by a program PIC16C55 microcontroller U1. That PIC also senses and records the bias of the LED's movement. This device was originally used for an application involving psychokinesis testing, where the person was asked to think the lights in either a clockwise or counterclockwise direction. Flashing neon Christmas lights, flashing Christmas LED display, dual flasher add-on for 555 circuits, variable frequency high power LED flasher, LED pulsar, variable frequency high power LED flasher, LED pulsar with audible output, simple lamp pulsar, LED flasher. Flip-flop circuits, trigger flip-flop, 2 amplifier flip-flop. This is a trigger flip-flop, 2 amplifier flip-flop. Frequency to voltage converter circuits, industrial frequency to voltage circuit. Sorry, that's in industrial frequency to voltage converter and a frequency to voltage converter. This is the industrial frequency to voltage converter. Frequency to voltage converter. It's mostly on an integrated circuit. This is an 80537. Can also be used to perform frequency to voltage conversion. Function generator circuits. Function generator, sweep/function generator, simple function generator, accurate stable function generator, wide range function generator. These 3 circuits make up an audio frequency function generator and can be individually used for custom applications. That's pretty involved. Sweep/function generator. Sine, triangle, and square waves. There you go. Sweep function generator continued. Simple function generator. It's a triangle wave output and a square wave output. Fair enough. Accurate stable function generator. Triangular wave output, square wave output. I'm not seeing a sine wave output. Supply limited oscillators usually are sensitive to temperature and power supply changes, are never symmetrical, and don't operate at high frequencies because the amplifier's output is saturated when it reaches the supply lines. The circuit shown, a function generator, can alleviate these problems. Its square wave output boasts a rapid rise time, quick settling time, and an amplitude that's temperature insensitive. Also, its triangular output waveform features a perfectly constant rate of change through its range. Amplifier A1 together with A2 generates a stable plus 10 volts. This signal, which is integrated using A3, C2, and R2, makes a negative going ramp. When the peak output of A3 equals minus 10 volts, the output of A1 and A2 change state, and the A3's output ramps up. When A3's output equals 10 volts, the outputs of A1 and A2 change state again, and new cycle starts. Wide range function generator. Game circuits. Electronic craps game, 21 game, first response monitor 1, Z dice game, 3 input first response monitor, electronic coin toss, electronic one-arm bandit, digital first to respond box, first response monitor 2, analog first response monitor, Wheel of Fortune. This is an electronic scrap game. It's basically just 2 dice. 2 gates of a 4093 quad 2-input NAND Schmidt trigger CMOS IC are connected in astable oscillator circuits as clocks. The two 4017 ICs have 6 LEDs connected to its first 6 outputs. As the clock pulses, enter pin 14 of the 4017S to IC count from 1 to 6 over and over as long as the clock pulses are present. When S1 and S2 are released, one of the LEDs in each circuit will remain on, indicating a number from 1 to 6. The circuit is set up so that you can roll the dice together by pressing S1 and S2 at the same time, or roll each die one at a time. 21 game. It's like blackjack, I suppose. First response monitor 1. This has got a microcontroller in it. The Z dice game. 3-input first response monitor. Electronic coin toss. Electronic one-arm bandit. The one-arm bandit circuit is made up of 3 clock circuits and 3 counter readout circuits. A single roll switch S1 turns all 3 clocks at the same time. S1 is closed, capacitors C4, C5 and C6 are charged. After S1 is released, the clocks run, taking energy from the capacitors. As the capacitors discharge, the 3 clocks begin to slow down, producing the effect of the drums on a mechanical bandit slowing to a stop. Digital first to respond box, first response monitor 2, analog first response monitor. Wheel of Fortune. Humidity sensor circuits. Humidity monitor. Digital relative humidity gauge. Humidity monitor. Digital relative humidity gauge. Indicator circuits. Model car derby winner indicator. Current indicator. Receiver signal strength indicator. LED output indicator for 555 circuits. Model car derby winner indicator. Current indicator. Receiver signal strength indicator. LED output indicator for 555 circuits. Infrared circuits. Audio modulated IR transmitter. Audible IR detector. Wireless IR headphone transmitter. TV remote control relay. Single tone infrared control transmitter. IR illuminator for night vision TV cameras and scopes. Low power infrared data link receiver. Infrared body heat detector. IR detector circuit. Steady tone infrared transmitter. FM infrared receiver for audio reception. General purpose IR receiver. Wireless IR headphone receiver. Pulse frequency modulated IR transmitter. Single tone infrared receiver. Audible output infrared receiver. Audio modulated IR transmitter. Audible IR detector. Wireless IR headphone transmitter. TV remote control relay. Single tone infrared control transmitter. IR illuminator for night vision TV cameras and scopes. Low power infrared data link receiver. Infrared body heat detector. Infrared detector circuit. Steady tone infrared transmitter. FM infrared receiver for audio reception. General purpose IR receiver. wireless IR headphone receiver, pulse frequency modulated IR transmitter, single tone infrared receiver, audible output infrared receiver, instrumentation amplifier circuits. Times 100 instrumentation amplifier, variable gain differential input instrumentation amplifier, programmable gain instrumentation amplifier for single supply applications, differential input instrumentation amplifier, high input impedance instrumentation amplifier, AC coupled instrumentation amplifier, low noise instrumentation amplifier, low power instrumentation amplifier, ultra low noise single supply instrumentation amplifier, times 100 instrumentation amplifier, variable gain differential instrumentation amplifier, programmable gain instrumentation amplifier for single supply applications, differential input instrumentation amplifier, high input impedance instrumentation amplifier, AC coupled instrumentation amplifier, low noise instrumentation amplifier, low power instrumentation amplifier, ultra low noise single supply instrumentation amplifier, integrator circuits. Integrator with bias current compensation, simple integrator, AC integrator. Integrator with bias current compensation, simple integrator, AC integrator. This op-amp circuit can be used with a wide variety of op-amps. The values RF and RI depend on gain, but will be 1 kilo ohm to 1 mega ohm in most cases. CF depends on the pole frequency needed. U1 is a 741 type op-amp. Interface circuits. Timer/AC line interface. Interfacing resistive transducers. Timer/AC line interface. Interfacing resistive transducers. All types of resistive element transducers such as servo, pots, level indicators, thermistors, photosensors, strain gauges, and so on can be directly connected to the AD537. The scale correction factor K is a function of the resistance, varying from 0.65 to 0.98 for values from 3 to 100 kilo ohms. Inverter circuits. SCR inverter and trigger circuits, simple inverter, vehicle audio amplifier inverter, positive to negative DC to DC inverter, 1 kilowatt 10 kilohertz sine wave inverter. SCR inverter and trigger circuit, simple inverter, vehicle audio amplifier inverter, positive to negative DC to DC inverter, 1 kilowatt 10 kilohertz sine wave inverter. Ion circuits. Negative ion generator, ion sensing electroscope, negative ion generator, ion detector. Negative ion generator, ion sensing electroscope, negative ion generator, ion detector. This circuit detects static charges and free ions in the air. It can be used to indicate the presence of ion emissions, high voltage leakage, static electricity, electrostatic fields, etc. The ground connection is made by either an earth ground or by touching an aluminium foil electrode with your hand. M1 is a 100 microamp meter. R3 is a sensitivity control. Laser circuits. High current drive circuit for single heterostructure laser diodes. 12 volt high voltage supply for HENE laser. Light beam receiver and sound effects generator for laser pistols. Laser diode transmitter. It's a pew pew pew. That's what a laser sounds like. Pew 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 pew. Laser diode transmitter. IR laser light detector. Phase lock loop IR laser light receiver. Op amp diode laser driver. Laser DC supply. IC laser diode driver. Pulse double heterostructure laser driver. High current drive circuit for single heterostructure laser diodes. 12 volt high voltage supply for HENE laser. What's HE and NE? I think HE is helium. And what's NE? Let me look it up. Yeah, so HE is helium and NE is neon. There you go. Might as well make a note in our notes about the He equals helium and Ne equals neon. Very good. Light beam receiver and sound effects generator for laser pistols. Laser diode transmitter. IR laser light detector. PLL IR laser light receiver. Op amp diode laser driver. Laser DC supply. IC laser diode driver. Pulse double heterostructure laser driver. Light controlled circuits. Traffic light sequencer circuit. Tachometer adapter. Sun tracking circuit for solar arrays. Optical fringe counter. Low noise light sensor with DC servo. Photodiode amplifier. Light switch LED blinker. Single supply photodiode amplifier. Light control monostable. Darkness monitor. Programmable light activated relay. Traffic light controller. Colorimeter. I've got a thing on my component drawers up here that's a color detector. I haven't used it yet, but I think it can actually detect colors. Yeah, I don't know what a colorimeter is. Let's have a look at that when we get to it. 8-decade light meter, LED light wave communications transmitter, LED light wave receiver, solar power supply with linear regulator, photodiode log converter transmitter, rechargeable solar power for sun tracker. Traffic light sequencer circuit, tachometer adapter, sun tracking circuit for solar arrays. The sun tracker uses a combination of 3 photoresistors to ensure that the circuit will follow the sun during the day, but not look for it at night. Optical fringe counter, low noise light sensor with DC servo, photodiode amplifier, light switch LED blinker, single supply photodiode amplifier, light controlled monostable, darkness monitor, programmable light activated relay, traffic light controller, colorimeter. Oh, it comes with code. It's Visual Basic. No, it's not Visual Basic. It's basic code. Isn't that interesting? So we've got a PC expansion bus. It must be talking about the ISA bus, mustn't it? Colorimeter. LED colors and codes. Blue, green, yellow, red, orange, crimson, aqua. I don't know what it's talking about because... Oh, okay. Okay. It must be a CRT that it's driving. I didn't think blue LEDs were available in 1996. A hardware/software combination activates. In turn, one of several LEDs emits a portion of the visible spectrum. A phototransistor measures the light reflected by the surface being measured, and an 8-bit analog to digital converter translates the phototransistor's output into a digital format that the computer can interpret. 7 LEDs, blue, aqua, green, yellow, orange, crimson, and red, provide a range of readings across the visible spectrum. Lack of spectral continuity among adjacent LED colors could skew results, so the circuit provides built-in compensation for this error. 2 simple basic programs control the circuit's operation. One allows you to define a set of standards by measuring known color samples and recording the values with an associated name. The other program measures unknown samples and provides the best match with the defined standards, as well as a relative error factor. Okay, so we've got 2 listings. Listing 1 is the calibration program, and listing 2 is the identification program. All right, so this is calibrat.bas, calibration program. CLS, key off, n equals 0, address equals 512, open equals R, 1, cal 1, 16, open. Oh, gee. I don't know how to program in BASIC. I used to know a little bit of BASIC. Wow. Well, I'm not going to read through that code now. Fascinating. 8-decade light meter. It just reminds me of how much I've forgotten. I used to know a bit of BASIC, like CLS, that's clear screen. I know that. But yeah, no, I forget all the details of BASIC. It's a long, long time since I used it. Although I suppose I still use VBA, which is BASIC at heart. Yeah. Wow. 8-decade light meter. LED light wave communications transmitter. LED light wave receiver. Solar power supply. Solar power supply with linear regulator. Photodiode log converter transmitter. Rechargeable solar power for sun tracker. Logic circuits. Logic state change indicator. Combinational logic multiplexer. AND gate. Relay AND gate. Sorry, that's relay AND circuit and relay OR circuit. Logic state change indicator. Combinatorial logic multiplexer. AND gate. Relay AND circuit. Relay OR circuit. Mathematical circuits. Low cost 1 quadrant multiplier / divider. Low cost accurate square root circuit. Low cost accurate squaring circuit. Bridge linearizing function. Square rooter. analog variable multiplier / divider, difference of squares, approximation for sine phi, simple analog averaging circuit, simple analog multiplier, delta percentage ratio computer, low cost 1 quadrant multiplier / divider, low cost accurate square root circuit, low cost accurate squaring circuit, bridge linearizing function, square rooter, analog variable multiplier / divider, difference of squares. A single AD 534 can be used to compute the difference of the squares of two input signals. The function can be useful in vector computations and in weighting the difference of two magnitudes to emphasize the greater nonlinearity. Approximation for sine phi. The AD 534 is remarkably easy to use. Blah, blah, blah. Seems to be pretty popular, the AD 534. Simple analog averaging circuit. Simple analog multiplier. Delta percentage ratio computer. The AD 534 again. Wow, there's a lot of circuits in this category. This is measuring and test circuits. Electronic level, single chip digital voltmeter, inductance with DVM measuring circuit, negative reference voltage circuit, precision current source, 1 kilowatt power meter, logic chip tester, power supply for 10 megahertz frequency standard, 3-terminal regulator current source, 4-wire resistance measurement hookup, audio frequency meter, ELF monitor, strain gauge sensor, minute marker, digital barometer, reference circuit, transistor matching circuit, auto ranging digital capacitance meter, frequency divider for 10 megahertz frequency standard, electroscope, optical isolator wattmeter, digital 3-phase wave generator, simple test audio amplifier, gate dip oscillator 1, accelerometer G meter circuit, gate dip oscillator 2, 2 remote meters, novel RF power meter, nano ammeter, 1.5 volt logarithmic light level meter, AC power monitor, 100 watt variable resistor simulator, IMD test circuit for pin diodes, VCO and input frequency comparer, ECG amplifier with right leg drive, power transformer tester, 4 to 20 milliamp process controller, simple high current measurer, analog circuitry calibrator, simple signal generator for signal tracing, simple harmonic distortion analyzer, sound subcarrier generator, inductance and capacitance determiner with SWR bridge, motorcycle tune-up aid, 50 megahertz frequency counter, 10 megahertz frequency standard, programmable capacitor circuit, programmable resistor circuit, electronic level, single chip digital voltmeter, inductance with DVM measuring circuit, negative reference voltage circuit, precision current source, 1 kilowatt power meter, logic chip tester, power supply for 10 megahertz frequency standard, 3-terminal regulator current source, 4-wire resistance measurement hookup, audio frequency meter, ELF monitor. A telephone pickup coil is used as a sensor for low-frequency magnetic fields. The signal is amplified and detected, then used to drive a comparator. Strain gauge sensor. Minute marker. Minute marker. I don't know what that is. The figure shows the schematic of a minute marker. The output of transformer T1 is 12.6 volts AC at 60 Hz, which is rectified by D1 and regulated by IC4, and LM7805 regulator to provide 5 volt DC for the circuit. The unrectified AC is bandpass filtered, blah, blah, blah. Digital barometer reference circuit, transistor matching circuit, auto ranging digital capacitance meter, frequency divider for 10 MHz frequency standard, electroscope. This circuit is useful for detecting electrostatic charges. Optical oscillator wattmeter. Digital 3-phase wave generator. Simple test audio amplifier. Gate dip oscillator 1. Accelerometer G meter circuit. Gate dip oscillator 2. 2 remote meters. Two remote meters can be driven independently using just one wire pair. This constant current design eliminates the effects of wire pair resistance up to 200 ohms. Driving 2 remote meters independently usually requires 2 wire pairs, 1 pair for each meter. Novel RF power meter. Nano ammeter. 1.5 volt logarithmic light level meter. AC power monitor. 100 watt variable resistor simulator. IMD test circuit for pin diodes. VCO, an input frequency comparer. ECG amplifier with right leg drive. Power transformer tester. 4 to 20 milliamp process controller. Simple high current measurer. Analog circuitry calibrator. Simple signal generator for AC signal, simple signal generator for signal tracing. Simple harmonic distortion analyzer. Sound subcarrier generator. Inductance and capacitance determiner with SWR bridge. Motorcycle tune-up aid. Performing a tune-up on a newer bike is made a lot easier with this helpful circuit. Because of the high voltages present, make sure that S1 has an insulated handle and that the fixture is grounded. "50 MHz frequency counter, 10 MHz frequency standard. Programmable capacitor circuit. Programmable resistor circuit. Metronome circuits. Audible metronome, visual metronome. Audible metronome, visual metronome. 52. Miscellaneous treasures. MOSFET drive current booster. Simple event counter. frequency doubler, atmosphere noise monitor, tachometer derived from brushless shaft angle resolver, vocal stripper power supply, single chip message system, television vertical deflection circuit, tone burst generator, audio volume limiter, simple intercom for noisy environments, ditherizer, triamp lamp dimmer circuit, 500 kilosamples per second 8-channel data acquisition circuit, hydrophone, your name in lights, underwater microphone, pulse echo driver, simple pseudo-random voltage source, TV horizontal deflection circuit, muting circuit, simple remote gain control, loop oscillator eliminator, 1 amp voltage follower, electronic fish lure, heartbeat transducer, contact debouncer, positive feedback cable terminator, 10 times frequency multiplier, Jacob's ladder, master slave device error checker, ground loop preventer, dual tone generator for audio servicing, diodeless peak hold circuit. These are miscellaneous treasures. They are quite miscellaneous. MOSFET drive current booster, simple event counter, frequency doubler. Doubler, oh, that's interesting. Atmosphere noise monitor, tachometer derived from brushless shaft angle resolver. Wow. Vocal stripper power supply. The schematic of the lead vocal filter is shown in the figure. Single chip message system. The ISD 1016 is a complete analog audio record/playback system on a chip. Alright. Television vertical deflection circuit, tone burst generator, analog volume limiter, simple intercom for noisy environments, ditherizer. In digital audio, a noise signal of amplitude less than 1 significant bit is often added to the audio to reduce the quantizing effect and improve the audio quality by trading digital noise for analog noise, which does not have the harsh sound. This circuit consists of a noise generator at a low level of noise to an analog signal to be digitized, or an analog signal from a digital source. Triac lamp dimmer circuit, 500 kilosample per second 8-channel data acquisition circuit. Hydrophone. A commercially available hydrophone transducer is used in this system. Your name in lights. This circuit will enable you to put a name or call sign in lights using 7-segment LEDs. The display will spell the desired name out sequentially. Select the correct type of LED. Solder the correct leads together to form the letters you want. After mounting the appropriate current limiting resistor, the 7445 can only sink 80 milliamp, so a PNP transistor is needed to handle the current required to light the letters. The heart of the circuit is a 555 oscillator and a 7490 decade counter, which is decoded by a 7445 open collector driver chip. Underwater microphone. Pulse echo driver, Simple pseudo-random voltage source. TV horizontal deflection circuit. Muting circuit. Simple remote gain control. Loop oscillator eliminator. 1 amp voltage follower. Electronic fish lure. The click-click sound lures fish to the vicinity. Heartbeat transducer. Okay, I'm going to write that one down. I'm interested in that. So, yeah, okay. So we'll say page 387, heartbeat transducer. Might build this particular circuit. Looks pretty simple, doesn't it? Contact debouncer. A contact debouncer using a Schmidt trigger, such as a TTL7414, provides a clean pulse from a switch contact closing. Positive feedback cable terminator. 10 times frequency multiplier. Jacob's ladder. A Jacob's ladder can be made from an old neon sign or oil burner ignition transformer. A rating of 12 to 15 kilovolts at 20 to 30 milliamps will be adequate. Master-slave device error checker. Ground loop preventer. Dual tone generator for audio servicing. Diodeless peak hold circuit. Mixer circuits. Simple audio mixer. Op-amp audio mixer. Simple audio mixer. Op-amp audio mixer. Model and hobby circuits. Model railroad crossing flasher. Model railroad track control signal. Model railroad crossing flasher. Model railroad track control signal. Modulator circuits. Varactorless HF modulator. Modulator for video. Digital pulse width modulation circuit. 4-quadrant multiplier as DSB modulator. Pulse width modulator. Linear AM amplitude modulator. Video modulator hookup. Varactorless HF modulator. Modulator for video. Digital pulse width modulation circuit. 4-quadrant multiplier as DSB modulator. Pulse width modulator. Linear AM amplitude modulator. Video modulator hookup. Morse code circuits. Active CW audio filter. Morse messenger. CW identifier with sine wave audio output. Simple code practice oscillator. Active CW audio filter. Morse messenger. CW identifier with sine wave audio output. Simple code practice oscillator. Motor control circuits. Precise DC motor speed controller. Accurate motor speed control. Motor direction control using discrete transistors. Long time delay motor control circuit. Full wave speed control for motors. SCR motor speed controller. Triac motor control circuit. Low voltage DC motor speed controller. Motor direction control. Precise DC motor speed controller. Accurate motor speed control. Motor direction control using discrete transistors. Long time delay motor control circuit. full wave speed control for motors, SCR motor speed control, triac motor speed control, low voltage DC motor speed control, motor direction control, multi-vibrator circuits, astable multi-vibrator with starting network, bistable multi-vibrator, astable with variable pulse width, one-shot multi-vibrator, basic 555 astable multi-vibrator, astable multi-vibrator. Astable multi-vibrator with starting network, bistable multi-vibrator, astable with variable pulse width, one-shot multi-vibrator, basic 555 astable multi-vibrator, astable multi-vibrator. Noise circuits, noise generator, Dolby noise reduction circuit, audio noise base voting circuit, adjustable noise clipper, simple noise limiter, noise generator, Dolby noise reduction circuit, audio noise based voting circuit, adjustable noise clipper, simple noise limiter. Operational amplifier circuits, basic op-amp circuits, op-amp with long RC time constants, op-amp offset null, basic op-amp audio amplifier, input guarding for high Z op-amps, enhanced op-amp balanced amplifier, paralleled power op-amps, single supply op-amp applications, current regulator op-amp, op-amp resistance multiplication circuit, pseudo ground, basic op-amp circuits, op-amps with long RC time constants, op-amp offset null. Offset problems can occur in the best of circuits, and often do, without regard to whether the circuit is inverting or non-inverting. Offset nulling potentiometers are useful in correcting the output to zero, but their effectiveness will vary under different conditions. Basic op-amp audio amplifier, input guarding for high Z op-amps, enhanced op-amp balanced amplifier, parallel powered op-amps, single supply op-amp applications, current regulator op-amp, op-amp resistance multiplication circuit, pseudo ground. For op-amp circuits, a pseudo ground is often needed. A voltage reference IC can be used. The analog devices 780 is used here for this application. This can sink or source current. Oscillators, audio, easily tuned sine wave oscillator, quad tone oscillator, one transistor phase shift oscillator, basic LM3909 audio oscillator, low distortion sine wave oscillator, low frequency astable, TTL based audio oscillator, variable duty cycle from astable, simple variable frequency oscillator, Wine bridge oscillator 1, Wine bridge oscillator 2, logic gate sine wave oscillator, easily tuned sine wave oscillator, quad tone oscillator, one transistor phase shift oscillator, basic LM3909 audio oscillator, low distortion sine wave oscillator, low frequency astable, TTL based audio oscillator, variable duty cycle from astable, simple variable frequency oscillator, Wine bridge oscillator 2, logic gate sine wave oscillator, oscillators miscellaneous, oscillators miscellaneous, variable frequency astable 1, astable oscillator 1, astable oscillator 2, variable frequency astable 2, quadrature wave oscillator, stabilized wire bridge oscillator, digitally controlled square wave oscillator, 50% duty cycle 555 circuit, varied rep rate duty cycle with 555, DDS digital VFO, variable frequency astable 1, astable oscillator 1, astable oscillator 2, variable frequency astable 2, quadrature wave oscillator, stabilized wire and bridge oscillator. There's the AD534 again. Uses a variable gain amplifier. Digitally controlled square wave oscillator. %50 duty cycle 555 circuit. Varied rep rate duty cycle with 555. DDS digital VFO. Oscillators, RF. Frequency modulated oscillator. JFET variable frequency oscillator. AM oscillator for wireless microphones. Ryan Arts oscillator. Remote oscillator high frequency VFO. Beat frequency oscillator for AM SW radios. SW shortwave, AM shortwave radios. Butler oscillator circuit. 455 kilohertz oscillator. Modified Hartley oscillator. VLF LC oscillator. Grounded bass. Tuned collector oscillator for AM broadcast band. HF VFO circuit. Darlington transistor oscillator. FM high frequency oscillator with no varactor. Tunable UHF oscillator. Universal VFO. Oscillator circuits. Colpitts oscillator. Clap oscillator for 100 kilohertz. Tuned collector oscillator. Hartley oscillator. Frequency modulated oscillator. JFET variable frequency oscillator. AM oscillator for wireless microphones. Reinhardt's oscillator. This oscillator uses inductivity coupled emitter and collector windings to its main tank circuit. Remote oscillator, high frequency VFO. Beat frequency oscillator for AM shortwave radios. Butler oscillator circuit. 455 kilohertz oscillator. Modified Hartley oscillator. VLF LC oscillator. Grounded bass tuned collector oscillator for AM broadcast band. High frequency VFO circuit. Darlington transistor oscillator. FM high frequency oscillator with no varactor. Tunable ultra high frequency oscillator. Universal VFO. Oscillator circuits. Colpitts oscillator. Clap oscillator for 100 kilohertz. Tuned collector oscillator. Hartley oscillator. Oscilloscope circuits. Scope voltage cursor adapter. Sampling rate phase lock. Differential amplifier for scopes. Delayed video trigger for scopes. Scope voltage cursor adapter. Sampling rate phase lock. Differential amplifier for scopes. Delayed video trigger for scopes. Photography related circuits. Charger for photo flash capacitor. Slide stepper. Photo superstrobe. Charger for photo flash capacitor. Slide stepper. Photo superstrobe. Piezo circuits. Piezoelectric driver circuit. Piezoelectric buffer. piezoelectric driver circuit, piezoelectric buffer. This circuit will serve as a buffer for experiments with Kynar film, a piezoelectric material, or with piezo devices. Power line circuits. AC power controller, AC power line monitor, power line modem for computer control, low voltage power controller. AC power controller, AC power line monitor, power line modem for computer control, low voltage power controller. Power supply circuits. Fold back current limiter, current limiting regulating circuit. Sorry, that's current limiting regulator circuit. Switching power supply, transformerless DC power supply 1, plus 5 volt at 1.5 to 3 amp supply, plus 6 to plus 15 volt input. Transformerless DC power supply 2, fast 3.3 volt regulator, power supply for high power auto sound amp, IC regulator protection, 3.3 volt switching regulator, NE602 power supply options, simple 9 volt power supply, tracking power supply, power efficient voltage regulator, low dropout regulator, SCR switching supply for color TV receivers, regulator circuit for bilateral source load power system, fast 3.3 volt adjustable regulator, 2-terminal 100 milliamp current regulator, 2-phase rectifier, low noise 5 volt supply, positive regulator with 0 to 70 volt output, simple 12 volt power supply, 3.3 volt from 5 volt logic supplies, 12 volt supply, 4 to 70 volt regulator, switched power control circuits, multiple on-card regulator adjuster, simple 9 volt power supply, 5 volt at 1 amp supply with 3 volt to 5 volt input, 5 volt DC regulated supply, buffered reference supply, 5 volt logic regulator with electronic shutdown, 12 volt DC regulated supply, junked transistor regulators, teleprinter loop supply, 5 amp constant voltage supply, fold back current limiter, current limiting regulator circuit, switching power supply, transformerless DC power supply 1, 5 volt at 1.5 to 3 amp supply, plus 6 volt to 15 volt input, transformerless DC power supply 2, fast 3.3 volt regulator, power supply for high power auto sound amp, IC regulator protection, 3.3 volt switching regulator, NE602 power supply options, simple 9 volt supply, tracking power supply, power efficient voltage regulator, low dropout regulator, SCR switching supply for color TV receivers, regulator circuit for bilateral source load power systems, fast 3.3 volt adjustable regulator, 2-terminal 100 milliamp current regulator, 2-phase rectifier, low noise 5 volt supply, positive regulator with 0 to 70 volt output, simple 12 volt supply, 3.3 volt from 5 volt logic supplies, 12 volt supply, 4 to 70 volt regulator, switched power control circuits, multiple on-card regulator adjuster, simple 9 volt power supply, 5 volt at 1 amp supply with 3 to 5 volt input, 5 volt DC regulated supply, buffered reference supply, 5 volt logic regulator with electronic shutdown, 5 volt DC regulated supply, junked transistor regulators, Old transistors can make excellent regulators. Simply use one as a zener to control the base current to another transistor. If the pass transistor cannot supply enough current, you can use two pass transistors in its place. Teleprinter loop supply, 5 amp constant voltage supply. Power supply circuits, high voltage. Fluorescent lamp, 12 volt supply. High voltage regulator. Night vision scope power supply. High voltage power supply control circuit. Minus 100 VDC supply. AC operated helium neon power supply. That's a laser again, isn't it? HV regulator with foldback current limit. Kirlian device supply. High voltage tripler. 200 volt regulator. Pulse width modulated laser supply. Fluorescent lamp, 12 volt supply. High voltage regulator. Night vision scope power supply. High voltage power supply control circuit. Minus 100 VDC supply. The combination Hartley oscillator / step-up transformer shown in A can generate significant negative high voltage, especially if the voltage output of the transformer is multiplied by the circuit in figure 69 5B. T1 is a small low voltage filament transformer of around 4 to 10 VAC output, 120 volt primary. AC operated HENE power supply. High volt, and we saw that earlier, that's a type of laser, isn't it? Yeah, it's a laser tube. High voltage regulator with foldback current limit. Kirlian device supply. High voltage tripler. 200 volt regulator. Pulse width modulated laser supply. Power supply circuits, multiple output. Experimenter's power supply, quad power supply, active backup power supply, CCFL supply with variable contrast, DC power source for experiments, stable VFO power supply, high efficiency triple output supply for notebook computers, general purpose power supply for automotive projects, plus or minus 15 volt power supply. Experimenter's power supply. Quad power supply. Active backup power supply. CCFL supply with variable contrast. DC power source for experiments. Stable VFO power supply. High efficiency triple output supply for notebook computers. General purpose power supply for automotive projects. Plus or minus 15 volt power supply. Power supply. Power supply circuits, variable output. Variable voltage regulator with current crowbar limiting. Adjustable 0 to 5 volt supply. Transceiver power supply for variable lab source. Adjustable power supply. Variable voltage regulator with wide range current limiting. General purpose 0 to 30 volt power supply. Adjustable positive regulator. Adjustable bias regulator. Variable voltage regulator with current crowbar limiting. Adjustable 0 to 5 volt supply. Transceiver power supply for variable lab source. Adjustable power supply. Variable voltage regulator with wide range current limiting. General purpose 0 to 30 volt power supply. Adjustable positive regulator. Adjustable bias regulator. Probe circuits. Current probe amplifier. Simple logic probe with alphanumeric display. Simple RF probe. 125 megahertz logic probe. pH probe amplifier. 8-digit 100 megahertz frequency probe. Current probe amplifier. Simple logic probe with alphanumeric display. Simple RF probe. 125 megahertz logic probe. pH probe amplifier, 8-digit 100 megahertz frequency probe. Protection circuits, short circuit protection circuit, polarity protector, short circuit protection circuit, polarity protector. The use of a four-diode bridge guarantees correct polarity irrespective of input DC polarity. Remember that 2 diode drops, about 1.2 to 1.5 volt, are lost from the input voltage using this circuit. Yeah, right. Radar detector circuits. Display board for radar gun, 2.6 gigahertz oscilloscope for radar speed gun. Display board for radar gun, 2.6 gigahertz oscillator for radar speed gun. Radiation detector circuits. Geiger counter, voltage tripler for radon detector ionization chamber. Flyback power supply for radon monitor. Radon monitor amplifier and head. Ion detector. Here's another Geiger counter, and I had a viewer suggest that I build the Geiger counter. There was one in the previous encyclopedia, and there's a particular like tube, a GM tube, something Geiger Muller or something, a GM tube, and they're about $50. So I could build a Geiger counter, but I'd have to get this tube. It's all based around that. The rest of it's just an amplifier. An HV generator, high voltage generator, and power to power a GM tube. A pulse from the GM tube is interfaced through Q2 and IC1 pulse generator IC3, which drives the speaker. Yeah, cool. So maybe one day we'll do a Geiger counter. There's a bunch of them that are options. I might as well make the note. It's page 531. Geiger counter. All right. This is a voltage tripler for radon detector ionization chamber. Flyback power supply for radon monitor. Radon monitor amplifier and head. Ion detector. Receiving circuits. AM radio. AC-DC vacuum tube AM and shortwave receiver. WWV receiver. Shortwave receiver. AM-FM receiver circuit. 118 to 136 megahertz aircraft receiver. Dual inverter line receiver. Toroidal core TRF shortwave receiver. 9-band shortwave receiver. 1-tube regenerative SW receiver. 1-tube regenerative AM receiver. 2-band radio. Simple crystal radio. Video line receiver. 2-chip AM receiver. Relay interface to RC receivers. Basic regenerative receiver. Simple radio receiver. 1-tube AM receiver. Balanced line receiver. Superhet front end. Receiver preamp. Regenerative receiver for 6 to 17 megahertz. Economy shortwave receiver. Variometer tuned radio. Old-fashioned crystal radio. WWV receiver. AM radio. AC-DC vacuum tube AM and shortwave receiver. WWV receiver. Shortwave receiver. AM-FM receiver circuit. 118 to 136 megahertz aircraft receiver. Dual inverter line receiver. toroidal core TRF shortwave receiver, 9-band shortwave receiver, 1-tube regenerative SW receiver, 1-tube regenerative AM receiver, 2-band radio, simple crystal radio, video line receiver, 2-chip AM receiver, relay interface to RC receivers, basic regenerative receiver, simple radio receiver, 1-tube AM receiver, balanced line receiver, superhet front end, receiver preamp, regenerative receiver for 6 to 17 megahertz, 2-stage TRF regenerative receiver, economy shortwave receiver, variometer tuned radio, old-fashioned crystal radio, WWV receiver. Reference circuits: low voltage reference, positive voltage reference, negative voltage reference. Low voltage reference, positive voltage reference, negative voltage reference. Regulator circuits: 3.3 volt 1 amp surface mount regulator, logic control of 78XX regulator, low cost step down regulator, dual output regulator, low noise regulator 5 to 3.3 volts, reducing ripple in a switching voltage regulator, low dropout 3-terminal regulators for new microprocessor applications, low dropout regulator, positive regulator sinks current, 5 to 3.5 volt surface mount switching regulator, 3.3 volt 1 amp surface mount regulator, logic control of 78XX regulator, low cost step down regulator, dual output regulator, low noise regulator 5 to 3.3 volts, reducing ripple in a switching voltage regulator, low dropout 3-terminal regulators for new microprocessor applications, low dropout regulator, positive regulator sinks current, 5 to 3.3 volt surface mount switching regulator. Relay circuits: latching relay alarm circuit, momentary relay circuit, latching relay driver for plus 12 volt loads, high impedance relay driver, latching relay driver, transistor relay driver, fast turn on delayed off relay circuit, low frequency relay oscillator, latching relay alarm circuit, momentary relay circuit. Latching relay driver for plus 12 volt loads, high impedance relay driver, latching relay driver, transistor relay driver, fast turn on delayed off relay circuit, low frequency relay oscillator. Sample and hold circuits: micro power 4-channel sample and hold circuit, low drift sample and hold, micro power 4-channel sample and hold circuit, low drift sample and hold. Sawtooth generator circuits: op amp linear sawtooth generator, sawtooth generator, op amp linear sawtooth generator using the LM324, and a sawtooth generator using the old 555. Scanner circuits: FM scanner noise squelch, scanner silencer, shortwave converters for scanners, FM scanner noise squelch, scanner silencer, shortwave converters for scanners. Siren, warbler, and whaler circuits: fire siren, warble oscillator, electronic siren, wailing sound generator, 2-tone siren. fire siren, warble oscillator, electronic siren, wailing sound generator, two-tone siren. Sound effects circuits: complex sound effect generator, dual tone generator, surfman sound generator, electronic whistle, bird chirp sound effect generator, robotic chatter sound generator, electronic wind chime, gunshot sound effects generator, complex sound effect generator, dual tone generator, surfman sound generator, electronic whistle, bird chirp sound effect generator, robotic chatter sound generator, robotic chatter sound generator continued, electronic wind chime, gunshot sound effects generator. Don't know if that's a good idea. Square wave generator circuits. Square wave generator, sharp square waveforms from multivibrator. Square wave generator, sharp square wave waveforms. Sharp square waveforms from multivibrator. Yeah, all right. Staircase generator circuits. Stepped triangle waveform generator, video staircase generator, free running staircase wave generator, up down staircase wave generator. Stepped triangle waveform generator, video staircase generator, free running staircase wave generator, up down staircase wave generator. Stepper motor circuits. Stepper motor pulse generator, stepper motor as shaft encoder, stepper motor encoder circuit, stepper motor pulse generator, stepper motor as shaft encoder, stepper motor encoder circuit. Switching circuits. Isolated switch, analog switched inverter, analog switch circuit, low output impedance multiplexer, op amp and analog switch R-on compensator, oscillator triggered switch, basic zero crossing switch circuit, analog switch, shunt pin diode switch, receiver band switching, resistor pin diode switch, digitally controlled 1 of 4 analog switch, pin diode switch, transceiver T transmit receive switch, series/shunt pin diode RF switch, auto off power switch, switch on delay circuit, hex FET switch circuits, alternating on-off control, audio controlled switch, switch debouncers, simple switch debouncer, analog switch circuit. Isolated switch, analog switched inverter, analog switch circuit, low output impedance multiplexer, op amp and analog switch R-on compensator, oscillator triggered switch, basic zero crossing switch circuit, analog switch, shunt pin diode switch, receiver band switching, resistor pin diode switch, digitally controlled 1 of 4 analog switch, pin diode switch, transceiver TR switch, series shunt pin diode RF switch, auto off power switch, switch on delay circuit, hex FET switch circuits, alternating on-off control, audio controlled switch, switch debouncers, simple switch debouncer, analog switch circuit. Sync circuits. PLD synchronizes asynchronous inputs. Sync tip DC restorer. Sync stretcher circuit. Synchronizer circuit. PLD synchronizes asynchronous inputs. A programmable electrically erasable logic PEEL device can easily supply the synchronizing function. Okay. Sync tip DC restorer. The DC restorer shown supplies a video signal with sync tips clamped to a baseline level. Sync stretcher circuits. Synchronizer circuit. Telephone related circuits. Telephone line tester, caller ID circuit, telephone call restrictor, telephone scrambler, universal telephone hold circuit, telephone ring amplifier, Bell System 202 data encoder, telephone audio interface, telephone recording circuit, telephone bell amplifier, phone line simulator, phone helper, telephone ring signal detector, telephone hold circuit, telephone line tester, caller ID circuit. This circuit requires programming of the microcontroller. It's a PIC16C55. Software is available from the reference. Telephone call restrictor, telephone scrambler. That's security through obscurity. Not a good idea. Universal telephone hold circuit, telephone ring amplifier, Bell System 202 data encoder, telephone audio interface, telephone recording circuit, telephone bell amplifier, phone line simulator, phone helper. This phone line simulator uses a 60 Hz transformer instead of a ring generator. The dial tone is provided by an NE555 astable oscillator. Telephone ring signal detector. Telephone hold circuit. Temperature-related circuits. Electronic thermostat, temperature controller, manual control for heater, proportional temperature controller, 8-input analog digital converter for temperature measurements, cold junction compensation for a grounded thermocouple, absolute temperature log with RS-232, centigrade thermometer with cold junction compensation, 1.5 volt electronic thermometer, 2-wire temperature sensor output reference to ground, 2-wire remote temperature sensor with sensor grounded, single supply temperature sensor -50 to +300 degrees Fahrenheit, basic Fahrenheit temperature sensor, temperature to frequency converter Celsius, temperature to frequency converter Kelvin, differential thermometer, optoelectric pyrometer, bar graph room temperature display, LM3911 temperature controller, thermocouple amplifier with cold junction compensation, precision RTD amplifier circuit for +5 volt, full range Fahrenheit temperature sensor, improved thermostatic relay circuit, thermocouple cold junction compensation, temperature differential detector, thermostatic relay application, temperature controller, temperature to digital output converter, freeze up sensor, zero voltage switching temperature regulator. Electronic thermostat, temperature controller. Manual control for heater, proportional temperature controller, 8-input analog to digital converter for temperature measurements, cold junction Cold junction compensation for a grounded thermocouple. Absolute temperature log with RS-232. Centigrade thermometer with cold junction compensation. 1.5 volt electronic thermometer. 2-wire temperature sensor. Output reference to ground. 2-wire remote temperature sensor with sensor grounded. Single supply temperature sensor, -50 to 300 Fahrenheit. Basic Fahrenheit temperature sensor. Temperature to frequency converter, Celsius. Temperature to frequency converter, Kelvin. Differential thermometer. Optoelectronic pyrometer. Bar graph room temperature display. LM3911 temperature controller. Thermocouple amplifier with cold junction temp compensation. Precision RTD amplifier circuit for 5 volt. Full range Fahrenheit temperature sensor. Improved thermostatic relay circuit. Thermocouple cold junction compensation. Temperature differential detector. Thermostatic relay application. Temperature controller. Temperature to digital output converter. Freeze up sensor. 0 voltage switching temperature regulator. Timer circuits. Alarm clock timer. Lamp timer. Long period timer. Alarm clock timer. Lamp timer. Long period timer. Tone control circuits. Treble control circuit. Bass tone control circuit. Combined bass and treble control. Active bass and treble tone control. Treble control circuit. Bass tone control circuit. Combined bass and treble control. Active bass and treble control tone circuit. A single transistor uses a feedback amplifier is connected with AC feedback through the tone controls, which determine the frequency response of the stage. Touch/proximity control circuits. Simple touch switch. Simple timed touch switch. Capacitive sensor system. Touch switch. Proximity alarm. Simple touch switch. Simple timed touch switch. Capacitive sensor system. Touch switch. Proximity alarm. Tracer circuits. Wire tracer. Cable tracer. Signal tracer. Wire tracer. Cable tracer. Signal tracer. This circuit uses a simple detector audio amplifier. The output can be connected to headphones or another audio amplifier. Transmitter and transceiver circuits. Wireless guitar transmitter. Micro TV transmitter. Wireless microphone. FM stereo transmitter. FM bug. Low power VHF beacon transmitter. Low cost 6 watt 40 meter continuous wave transmitter. Wireless guitar transmitter. Micro TV transmitter. Wireless microphone. FM stereo transmitter. FM bug. It's pretty simple looking, that FM bug. I wonder if we could make an FM transmitter with it, maybe. My writing's a bit terrible. It looks pretty simple. It's very, very simple. It's got some coils in it. Oh no, they're just 0.5. Oh, they're just inductors. That's no problem. Low power VHF beacon transmitter. Low cost 6 watt 40 meter continuous wave transmitter. Ultrasonic circuits. Ultrasonic remote control tester, ultrasonic motion detector, ultrasonic continuous wave transceiver, ultrasonic proximity sensor, simple ultrasonic generator, ultrasonic sound receiver, ultrasonic remote control tester, ultrasonic motion detector, ultrasonic CW transceiver, ultrasonic proximity sensor, simple ultrasonic generator, ultrasonic sound receiver. Video circuits. Video titler, video amplifier, RGB video amplifier, 1 of 2 video selector, NTSC to RGB converter, video IF amplifier / detector, video cable driver, simple NTSC grayscale video generator, LM1201 video amplifier, simple video grayscale generator European line standard, video switch, adjustable video cable equalizer, video summing amplifier, video amplifier, twisted pair video driver / receiver circuit, 250 milliamp, 60 megahertz current feedback amplifier for video applications, video driver / amplifier, video line driver, video titler, video amplifier, RGB video amplifier, 1 of 2 video selector, NTSC to RGB converter, video IF amplifier detector, video cable driver, simple NTSC grayscale video generator, LM1201 video amplifier, simple video grayscale generator European line standard, video switch, adjustable video cable equalizer, video summing amplifier, video amplifier, twisted pair video driver / receiver circuit, 250 milliamp, 60 megahertz current feedback amplifier for video applications, video driver / amplifier, video line driver, voltage controlled amplifier circuits, voltage controlled amplifier, voltage controlled audio amplifier, voltage controlled amplifier, voltage controlled audio amplifier. Sorry, that was my phone. Where were we? Voltage controlled amplifier circuits, a voltage controlled amplifier, and a voltage controlled audio amplifier. Voltage controlled oscillator circuits, 3-decade VCO, voltage controlled 2-phase oscillator, 3-decade VCO, voltage controlled 2-phase oscillator. Voltage measuring circuits, meter amplifier for 1.5 volt supply, voltage monitor, AC voltmeter has unique features, DC voltmeter, expanded scale DC meter for 12 volt systems, simple 3-digit DVM, inexpensive voltage calibrator, double-ended voltage monitor, audible voltage indicator, low drain meter amplifier for 1.5 volt supply, voltage monitor, AC voltmeter has unique features. Though it's built with standard components, this AC voltmeter contains many features not typically found in commercial meters. The most unusual is a selection of rectification modes. DC voltmeter, expanded scale DC meter for 12 volt systems, simple 3-digit DVM. That's a digital voltmeter, isn't it? Inexpensive voltage calibrator, double-ended voltage monitor, audible voltage indicator, low drain meter amplifier, waveform generator circuits. simple triangle waveform generator, triangle wave generator, generate accurate pulse width modulated signals, triangle wave generator, low frequency pulse generator, sine/cosine audio generator for galvanometer experiments, basic 555 monostable, op-amp sawtooth generator, digital sine wave generator, signal source for audio amplifier/inverter, simple test signal generator, simple triangle waveform generator. Actually, I'm just going to take a quick break. Sorry, back. So yeah, we've got the simple triangle waveform generator, triangle wave generator, generate accurate pulse width modulated signals, triangle wave generator, low frequency pulse generator, sine cosine audio generator for galvanometer experiments, basic 555 monostable, op-amp sawtooth generator, digital sine wave generator, signal source for audio amplifier/inverter, simple test signal comparator, waveguide circuits, 10 GHz waveguide detector for amateur radio use, 10 GHz waveguide transition for amateur radio use, 10 GHz waveguide detector for amateur radio, 10 GHz waveguide transition for amateur radio. White noise generator circuits. Zener diode white noise generator, white noise generator. Zener diode white noise generator, and white noise generator. Here, a 2N3904 EB junction is used as a noise generator, reverse biased. C is chosen to pass the lowest desired frequency component of the noise. All right, and then we're up to sources. So that'll be a long list of sources. Sources. All right. And then the index. And this is, of course, a cumulative index. So it lists all of the previous volumes. This is, of course, volume 6. So there's a lot of previous volumes. I think they've got some advertising after the index, which is why I'm flipping through. We'll get to the end of it and then see what they had to say for themselves about their other books and such. It's always fun to get that blast from the past, stuff that was relevant 20 years ago. About the authors. Robert F. Graf has 45 years of engineering, sales, and marketing experience in the electronics field. He has written more than 30 books, about 3 million copies printed, and well over 100 articles. He is a senior member of the IEEE, a licensed amateur radio operator, KA2CWL, and has a BSEE degree from Polytechnic Institute of Brooklyn and an MBA from New York University. He is self-employed. William Sheets is a self-employed circuit design engineer. He has more than 25 years of experience in RF, analog, and digital electronics. He has written numerous articles in electronics publications and co-authored 5 books with Graf. His interests include amateur radio, K2MQJ, photography, and travel. He has designed and built numerous items. including a satellite TV system, many transmitters and receivers, and a computer. He has an MEE degree from New York Uni, is married, and lives in upstate New York. There you go. What have we got here? Now you can access 1,000 of the most popular circuits with the Encyclopedia of Electronics on CD-ROM. Oh gee, I'd love to have that. That's great. Make the most of the power and flexibility of CD-ROM technology with the new CD-ROM version of the Encyclopedia of Electronic Circuits, featuring 1,000 of the most popular circuit drawings from the 5-volume set and an easy-to-use schematic viewer from Mental Automation. This valuable tool allows you to locate specific circuits and then review and print them out. An 800 number is also available for access 4 locked products on the CD-ROM. SuperCAD, a full-feature schematic editor, SuperSim, a digital simulator, SuperSpice, an analog simulator, and SuperPCB that creates printed circuit boards. Minimum hardware requirements: IBM PC or compatible, 386/33 with 4 megabytes of RAM, 3 to 10 megabyte hard disk space, VGA monitor or better, Windows 3.1 or higher, CD-ROM drive with Microsoft extensions. Yes, please rush me the Encyclopedia of Electronic Circuits CD-ROM for just $99 plus $9 shipping and handling and applicable taxes. Satisfaction guaranteed. All right. So that's it. We made it through to the end. So I'll throw over the farewell cam. We'll wrap up. That's a wrap. So 6 down, 1 to go. I had fun reading this book. We did make a few notes. So we learn a few things. Not many things, but a few things. Automatic gain control, automatic level control, intermediate frequency, helium, neon. And the helium neon thing was the laser. And we made a note for 3 circuits. Page 387 was the heartbeat transducer. Page 531 was the Geiger counter. And page 663 was the FM bug. So I might check out those particular circuits at some point in the future. Saturday is Electronics Project Day usually, so that's tomorrow. Although the circuit I'll be doing tomorrow is just our favorite thing, making cables. I'm going to be attaching these hook clips to these banana jacks. So yeah, that's what I'll be doing tomorrow. But that's the end of this video. So we've made it to the end. I hope you enjoyed this video. Thanks very much for watching. And please remember to hit like and subscribe.